So next up on this virtual system series, we're going to run through the configuration of the different options for inter-VSYS traffic flows. And we're also going to do some tests and show what the outputs are when we're passing traffic from one virtual system to the other using the different options. So we'll get straight into it. So the first scenario we're going to look at is traffic originating from LAN 1 go on VSYS 1, and that traffic is going to terminate there on DMZ2, which is in VSYS 2. Now the flow, or the way that that's going to get there, is going out of WAN 1 and then coming back in WAN 2. So it's going to go across two virtual systems, but it's going to actually leave the firewall and get bounced to DMZ2 using a destination NAT policy. So let's look at what this looks like when we're setting it up on the firewall. So I'm going to want to get traffic to come from LAN 1 on virtual system 1 to DMZ2 on virtual system 2. And in order for it to do that, it's going to egress WAN 1 and ingress WAN 2, hit a destination NAT policy, and get redirected to DMZ2. So this is inter-VSYS traffic that leaves the firewall but just goes from one virtual system to the other. Now, when I was setting this up in the earlier video, I done both of these addresses as DHCP. In order for the destination NAT policy to work, I've had to move that to a static address, and I've had to add in a static default route going to the default gateway on that virtual router LR2. Okay, so let's go ahead and create the policy on virtual system 1, allowing the traffic out to this web server. Now it's going to be on a non-standard port, so this rule base only allows traffic over its standard ports. So I need to create a policy to allow traffic to this web server on its non-standard port. So LAN to web server. Destination address is going to be under WAN 1, and I'm just going to specify the 22.56. So that is effectively the WAN 2 interface, where we are going to be hitting that and then hitting a destination NAT policy to the actual web server. Now the application will be web browsing, and the service, I'm going to create a service in here. So I'm going to call this web server service. I'm going to specify it's shared so it can be accessible on both virtual systems, 8080 and action equals allow. And I'll move that top down in a moment. Okay. Now I'm going to, on virtual system 2, I have to create a security policy and a NAT policy. I'm going to create the NAT policy first. Cut this down. So we're creating a destination NAT policy. So static IP, specify the internal server's address. On the original packet, I'm specifying the service, which is the 8080, destination interface, WAN 2. I could specify the address in here, which is going to be the 192.168.22.56 destination address. Okay, that's in there. Now creating the security policy to allow that flow now. Now I do specify the DMZ2. The destination address is still going to be that 192.168.22.56, because when the security policy is being evaluated for a destination NAT policy, for a when we're using a destination NAT policy, it's looking at the the NAT hasn't been evaluated yet, so we specify the destination address as that. Web browsing. Specify my servers. I'll go ahead and click OK on that. And I go and move that to the top. And that should be really it. So I'll go ahead and commit that, and I'll generate some test traffic. So that commits after going through. And I'm generating some test traffic now from virtual system 1 to virtual system 2 to this web server. Get rid of some of these columns. And looking at this filter, we can see this test traffic now, is going from virtual system 1 all the way through to virtual system 2. Now there's actually two sessions created here. So for that session, there'll be the session from virtual system 1 going outbound, but there'll also be a corresponding virtual system 2 session created coming from WAN 2 to DMZ 2. So this will be a separate session created, and we can see that there. So that just that kind of this shows the flow and what we have to do to configure inter-VSYS traffic that has to leave the firewall. Okay. So as part of this kind of testing as well, I'm going to upload a file over from one virtual system to the other using the different scenarios, and see what's the quickest. So it's going to be the same file size, same file, uploaded across multiple different scenarios. So yeah, we'll be able to kind of see it here. I'll just move that one over, and we'll do a split screen. So this is going to show the output. So this is when nothing's been uploaded. You can see all the data plane resources are quite zero. It's all low, packet descriptors and all. So I'm going to kickstart an upgrade. I'll just start recording, so I'll be able to do a split screen, and I'm going to choose a file, and I've tested this a few times. So this is going to just kind of focus on this file. It's just over it's 2 gigabytes big. So we'll start uploading that, and this is traffic scenario 1 that's leaving the firewall. So you can see okay, so it's kind of spiked a little bit there. What about the packet descriptors? 36, 40 is a kind of high. Buffers has gone up to about 4%. Not seeing much massive increase on the data plane CPU on the GUI there. We'll keep a look. So we can just give us an idea. It's going to give us an idea. So again, on the packet descriptors here, highest I'm seeing at the moment is 50. The reason I'm doing these kind of tests is depending on how you route your inter-VSYS traffic, it's going to have a very different impact on your firewall. So session offload becomes important. So inter-VSYS traffic that doesn't leave the firewall can't be offloaded. So that can have an impact on performance. So that file's gone through. It's taken 65.87 seconds. So we'll test the other scenarios and just see what they correspond to. But packet descriptors wise, it didn't go above. It didn't go 52% seemed to be the highest. Okay. So the next scenario we're going to look at is when traffic needs to go between two virtual systems, but we want it to stay on the actual firewall itself or within the firewall itself. And to do that, we need these external zones of type external, and they can communicate across virtual systems without effectively the need to cable up between them. So that's going to use interlogical router static routes between LR1 and LR2 across these external zones. So let's look at how that's done. So I guess a good place to start first would be creating the external zones. So go into zones, add, we'll call this VSYS1 external. Location is VSYS1. Set up a log setting. It's going to be an external type external zone. Very important part in here, you have to specify what VSYS is going to connect to. So this is VSYS1 external, it's going to connect to VSYS2. So if you don't put the VSYS2 in there, it can lead to all sorts of packet flow troubleshooting. The behavior will be the packets will just get dropped. You won't get a log, even with all the kind of static routes to and from the different virtual systems. You need to specify the destination virtual system in there. I'll go ahead and just click OK on that one, and I'm going to create the same one for VSYS2, external zone for VSYS2, and vice versa. Then just have it that its buddy or peer is the VSYS1, so mirroring it back. Alright, so they're the two external zones. What else do I need to do? I need to create a security policy going from the LAN to that external zone. So this will be LAN to LAN -1 to external. Go into LAN 1. Destination is going to be the external, the web browsing service. We have the web server service, and we log at session start. Now I can specify the destination IP address in here. The destination IP address is going to be the private address. So in this case, it'll be the 10.20.1.11. Okay, and I can move that top because it's more of a specific rule policy. From a NAT policy point of view, I don't need anything because it's going directly over the external zone. So that's the policy set up, the zone set up. Now that subnet, I'm going to need a static route in the virtual router. So if I go into logical routers, LR1, go in here and say route to VSYS2. It's going to be a 10.20.0.0/16 subnet. Leave the interface blank. Next hop will be next LR, and next hop will be LR2. And we're going to do the opposite just while we're on the virtual systems in here, or on the logical routers here. So I want to do it return route, route to VSYS1, and that's 10.10.0.0/16. Next hop is LR1. Click OK there. Now, apart from specifying in the external zone what zone it needs to be forwarded to, we need to also tell it in the virtual systems config here. And because I've specified next LR in there, it's already shown it up. But just to double check, that has to be selected. So if that's not selected, it won't show. The traffic won't work either. Okay, so that's all grand. If I go now into policies and set the policy up on VSYS 2, and so this will be external to DMZ-2, and that's coming in from VSYS 2 external. Destination in this case is the DMZ2. Destination address is the 10.20.1.11 address. It's going to a web browsing application, and it's going to a particular port, the 8080. We want to allow it, and we log it at session start as well for troubleshooting. Go ahead and move it up the top to show, and we'll commit that. So that's done, and that commit's gone through. So I'm going to generate some test traffic on the test PC. Let's see what happens. And that traffic loaded up straight away. So what do we see in the logs? All right, cool. So you're seeing from the start session, you're seeing LAN 1 going to the external zone. LAN 1 going to the external zone. That's one session ID. And then the external zone on VSYS 2 start going to the DMZ2. So you're seeing the kind of two flows, two session IDs created. So that's the kind of the traffic passing internally on the firewall using the external zones and the virtual systems. So again, we're going to test for scenario 2 the same file upload, see how quick, see how long it takes. So I'm going to start recording on the other one. So choose the file, the same file as I have chosen for the other speed test, and we are ready. So just before I start uploading, I'm just going to do an output from the CLI. So you see it's all pretty low. There's nothing happening on this firewall before I click this upload. So I'm going to start the upload now, and that's starting to upload. Straight away we're seeing the few spikes there. Okay, nothing dramatic, too serious at the moment. Okay, interestingly, it's gone 57 there, 66, where 52 was the highest it went up to on the previous scenario. 72. So seeing much higher numbers there on the packet descriptors. $70, pretty high numbers there. The upload's still going. 71. Much more higher usage on the packet descriptors than the other method though. This is routing the traffic internally. And uploads complete. Took 99 seconds compared with 60 odd on the scenario 1 method. So that's interesting. We'll continue with the testing. So the next scenario we're going to do is using the shared gateway and also a shared virtual router. So previously we had a dedicated virtual router for each virtual system. We can have a shared virtual router for all the virtual systems, and then for an outbound connection using a shared gateway. So we'll see how to configure this on the Palo Alto Networks firewall now. So the next scenario, we're going to use a shared logical router. So both VSYS 1 and VSYS 2 is going to use the same logical router, and we're going to use a shared gateway. So Ethernet 1/4 is going to become a shared, what's known as a shared gateway. So all the internet traffic is going to egress out this interface. Okay, so we'll do, first thing we'll do is create a shared logical router. And while I'm here, I'm going to remove the static routes that are on the old LRs, because they will cause a problem in this to kind of tidy it up or kind of switch. So I'll remove them. And I'm going to add that shared logical router now to the interfaces I can add it to. So add it in here. Management profile there is the warning that it keeps giving me. So remove that there. Don't need that anymore. Now, I purposely jumped past Ethernet 1/4 because I can't switch that for the moment, so I'll come back to that one in a second. Remove that as well. So it's all right having a management profile on your interfaces for maybe testing when you're doing deployments or that, but leaving them on it indefinitely isn't a good idea. It's increasing the kind of blast radius of who can access, well, depending on what your management profile is. If it's just ping, fair enough, but this one's ping and SSL. But yeah, there's use cases for it, but if you don't need it on it, remove it. Okay, so I've added on the ones that I can on into this shared gateway. I don't need to add an Ethernet 1/1 because that's the old VSYS 1 route out to the internet. So I can just leave that there for the moment like that. Now I need to create a shared gateway. So if I go into shared gateways, I'm going to add one called one. It's not going to let me specify an interface in there yet, so I'll just leave that blank. I'm going to go back to my interfaces now, and I want to move Ethernet 1/4 from VSYS 2 to that shared gateway. Now it mightn't show up immediately in here. It might just take a moment or two to show up. And when it does show up, which is there, the security zone is going to be gone. So I need to add in a new security zone. I'm going to call this outside. Add in the log setting. Go ahead and just click OK on that one. Okay, so interfaces for the most part are set up. One thing I will do is update this comment and just say this is now a shared gateway. Comments just make it easier from looking at that from that view. So that's fine. I want to go in now to my zones, and I want to tell the zones about the this external zone about the shared gateway. Now that it's going to be communicating with the shared gateway. I don't need to make it visible, so just add it in here. I don't need to make it visible in the other area, the virtual systems there, visible virtual systems, because the shared gateways are visible to all other external zones anyway. Now I can remove these guys because they're no longer needed. The LRs, we're using the shared one. We don't specify the shared logical router in there, so that's all fine. Now from a policies point of view, I need to create a NAT policy for traffic that hits the shared gateway. I needed to bind it to Ethernet 1/4. So I'll just call this outbound. The source zones I'm going to leave as any, and any traffic going to the outside zone, translate it to Ethernet 1/4 in this example. That's fine. Now from a tidy up point of view, I need to remove the old NAT policies or it'll cause commits to fail, because that's still referencing Ethernet 1/4. And not that it matters, but I'll do it anyway. I'll remove this one because we're not using Ethernet 1/1, but just for, there's no use having policies there if we're not using them. Now from a security policy point of view, I have a policy LAN to VSYS external. Now my outbound traffic flows will also be along that flow, so I'm going to change the WAN 1 destination zone to VSYS 1 external, and VSYS 1 external there too. So that'll accommodate the traffic going between the VSYSs, but this is going to accommodate the traffic going out to the internet, so as long as the application's using its standard ports. And I'm going to do the same on VSYS 2. Update WAN 2 to VSYS 2 external. And if you want to, you can do that. There's much of a muchness. You still have to click into it if you want to remove the WAN. So that is not quite everything. Okay, so you have to go back in here, and I need to so I've moved everything into the shared logical router. All the interfaces into that shared logical router. It's shared amongst all the virtual systems. I have my NAT policy for the shared gateway. I have my policies. I've everything almost, except my static route out. So I need to have a default route out to the internet, telling it about about Ethernet floor 4. So Ethernet 4 is not associated with this shared VR logical router yet, so need to do that. That's still associated with LR2, so let me update that. So that's sorted, and now now I can tell the static route to use that direction. So default route, destination, interface, Ethernet 1/4. Next hop will be an IP address, 192.168.22.1 in this lab network. So go ahead and click that, and probably forgetting something else, but we'll roll it at that for the moment. And do a quick test on traffic once that commit goes through. Commit's almost there. And that commit went through successfully. So we'll generate some traffic there now and check the inter-VSYS traffic between the LAN 1 and the DMZ2, and some outbound traffic flows as well. So I can tell you the inter-VSYS traffic looks like it's passing still anyway. Just open up another incognito. Yeah, inter-VSYS traffic is passing, so let's look at that. So that's the checking a web server from port 8080. So let's start, session starts, and we'll get them sessions to end now in a second. And so the inter-VSYS traffic is passing. What about traffic to the internet? Yep. Okay, looks like it's passing. And we'll check it from both virtual systems. So I know VSYS 1 out to the internet is working. And VSYS 2 out to the internet is working as well. So, pretty kind of basic example of two virtual systems using the same shared gateway and sharing a VR as well. Okay. So we're going to test the speed for scenario 3 again, using the internal virtual system external zone method. The only difference with this scenario and the last scenario for this file transfer is it's all in the same logical router as opposed to the other one, which was using the router next hop, logical router next hop. So we'll just show that the resources are quite low. There's nothing really happening. I'm going to start recording on the test PC and start. The upload has been started. And it was 72 round the packet descriptors was the highest that it went to. 71, 72 in the last one. These numbers look quite consistent. $71 there. That one. $71 again. So very similar numbers really as you would probably expect. It's not much of a difference. It's still using the external zone to switch this file. Be interested to know how long the file transfer will take. It's the exact same file. And that's complete. So it took 95.76 seconds. Stop that recording. And yeah, so in and around the same as the previous scenario too. So we tested the different ways of passing the traffic from one virtual system to the other, how they are configured locally on the firewalls themselves, and then ran some speed tests. Summary of those and performance test. Summary of those are when the traffic was leaving the firewall and going from one virtual system to the other, but when it left the firewall and came back into it effectively, we hit around 52%. 52, 53% on the packet descriptors, and it took 65 seconds for approximately a 2 gig file to get passed over with content inspection enabled. And then we had just to clarify, all 3 tests had content inspection enabled. And the next test or next scenario was using the external zone and routing the traffic internally on the firewall, and that used 71% of the packet descriptors, and it took 99 seconds for that same file type that took 65 seconds to pass through. So there was there's a significant cost there compared with the traffic leaving and coming back in. And then we tested it again on the The scenario 2 was where we had dedicated logical routers. Scenario 3, we had a shared logical router, and we seen a marginal increase in speed there. Packet descriptors usage was the same at around 71%, but the file transfer took 95 seconds. So it was marginally quicker. So what did these kind of tell us? From the outset, for sure, it looks like the traffic leaving the firewall and coming back in for inter-VSYS traffic is not just more efficient on the processing side, but it's more efficient on the time that it takes to get there as well. Okay, so the next big test that we want to do after doing these tests is looking at virtual systems being enabled and configured from Strata Cloud Manager. So that will be the next video. Cheers.